Alright, so today we are on 3-4, imaginary and complex numbers. So if you had me for Algebra 2, you remember me always saying you can't take the square root of a negative number until Algebra 2, so today is that day. So let's do square root of 36. So every square root has every number has two roots, right? One positive and one negative. So square root of 36 is plus or minus 6. So here's the problem we run into here. So we actually now have a value, and we're going to say that I squared, we're using the letter I for imaginary. I squared has the value of negative 1. So if I were to take the square root of both of those sides, I equals the square root of negative 1, which now helps us deal with all these negatives in here. So you could actually write this number as the square root of 25 times the square root of negative 1. We know the square root of 25 is plus or minus 5, and now you know that the square root of negative 1 is the letter I. Okay. So negative 50 we can break into, if you can use your perfect squares, be sure to use them. Let's do those really quick. So 1 squared is 1, 2 squared is 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and so on and so on. Okay, 225, and you can keep going. The main ones you're going to use are in this first column over here. Okay, so for negative 50, we could write that as square root of 25 times the square root of 2 times the square root of negative 1. Square root of 25 is plus or minus 5. Square root of 2 is going to stay in the radical over here because we can't simplify that, and square root of negative 1 is I. Okay? So let's think about when we're squaring these now, what we have. So I equals the square root of negative 1. We know that I squared equals negative 1. Well, when I have I cubed, I essentially have I times I squared, which are these two values multiplied together. So I now have, we're just going to call that I. So I times negative 1 would be negative I. And if I have I squared, that's really I to the fourth, that's really I squared times I squared. So negative 1 times negative 1 would give us positive 1. So when we go to I to the fifth, we really have I squared and I to the third. Or we have I to the fourth times I to the fourth times I. So the value for I is just I, the value for I to the fourth is just 1. So again, we have I. When we have I to the sixth, we have I to the fourth times I squared. So we have 1 times negative 1 gives us negative 1. So what you're going to notice is this pattern is going to start repeating. The easiest way to find the value of these is that that pattern repeats every fourth power. So all you need to do is divide that exponent by 4, figure out what its remainder is, and that will tell you where it fits in that pattern of 4. So 15 divided by 4, 4 goes in there 3 times with a remainder of 3. So it's the equivalent of I to the third, which will give us a value of negative I. 34 divided by 4 goes in 8 times with a remainder of 2. So it's equivalent to I squared, which is a value of negative 1. Okay? So now let's use what we know so we can solve some of these equations down here. So just like I would solve any equation, I'm going to try and isolate that variable. So I need to divide negative 2 from both sides. So I get negative 9 equals n squared. Take the square root of both sides. Before today you weren't able to do this, but now you are. So n equals square root of 9 times the square root of negative 1. So plus or minus 3 is the square root of 9, and the square root of negative 1 is I, equals n. In the second example, we need to subtract 1 from both sides, so I get x squared equals negative 7. Take the square root. 7 is not a simplifiable radical, but the negative 1 can be pulled out of there. So you have x equals plus or minus I, which is that negative 1, right? Negative 1 times 7, and the square root of 7. Okay, on your notes, the negative 56 was left off of this problem, so please add that in. You're going to add 2 to both sides, so you get 3y squared equals negative 54. divide both sides by 3. You get y squared equals negative 18. I can take the square root of both of those sides. So essentially, anytime you see a negative in the radical, you know you're going to pull an I out of that. Okay? And actually, let me write that correctly. Plus or minus I. And then this is actually square root of 9 and square root of 2. So the square root of 9 is 3. So put that there. And you'd have square root of 2 equals y. Let me write that a little bit neater for you. So y equals plus or minus 3i square roots of 2. So in all these problems we've done so far, these are all just monomials, right? Single term polynomials that we've done. So complex numbers involve two terms, and this is the standard form for a complex binomial. Okay. The a always represents the real number, and the b term, which is always attached to the I, represents the imaginary number. Okay. So for example, if I had 4 plus 5i, 4 would be the real number, and 5i would be the imaginary number. Okay, moving on. So, you can actually graph complex numbers. And because of what we just learned, where this is the standard form, and this is real, and this is imaginary, you translate that to a coordinate plane, your horizontal axis is going to represent the real numbers, or the a, and the vertical axis is going to represent the imaginary numbers, or the b. Okay? And here you're graphing a point. Not a line. So actually graphing complex numbers is really easy. So we're going to go on our real axis over 4, 1, 2, 3, 4, and then on our imaginary direction, which is vertical, 1, 2, 3, 4, and we're going to go up 1, 2, 3, 4, 5. So that's point A. Point B, I would go over 2 to the left and down 3, so it's going to be right there. Here, now I don't have both parts of that, so if I don't have a real number there, I can actually write that as 0 plus 3i. So I'm not going to go any in the horizontal direction, I'm going to go up 3. Same can be said here. I don't have a letter D, you should have had the number 4, and there is no imaginary, so that would be 4 plus 0i. So I'm going to go over, certainly label this one, go over 4 to the right, 1, 2, 3, 4, and then I'm not doing anything in the vertical direction, so that's going to be D. Alright, so let's solve some of these, and you're done. Okay, so I need to get that n isolated. Can't do that till I get that square root out of there. So let's take the square root of both sides. So now I know, the easiest way to think about this is square root of 25 is plus or minus 5. Because of the negative 1, stick an I behind it. So you get plus or minus 5i equals n minus 1. Squares and square roots cancel each other out. Now you just need to add that 1 to both sides. And correct form is always going to be the a plus bi form. So the real number is going to come first, the imaginary number is going to come behind. So in this case, we would have n equals 1 plus or minus 5i. Okay, next one, subtract 8 from both sides. So you get x plus 3 squared equals negative 2. And I need to take the square root of both sides. So I get x plus 3 equals plus or minus, remember this is square root of 2 and square root of negative 1, so it's plus or minus I square roots of 2. And then I need to subtract 3 from both sides, so I get x equals negative 3 plus or minus I square roots of 2. Pretty easy, yeah? Alright, let's deal with the last one. And again, there was a number dropped off when it printed. I'm not quite sure how, but we'll just fix it. So that should be a negative 1. So again, want to get that y isolated, we've got to move all of this around. First thing I'm going to do is subtraction, get that 7 out of there. So I get 1/3 y plus 2 squared equals negative 8. Now, I want to get to this, but I need to deal with this 1/3 first. So the opposite of multiplying by 1/3 is dividing by 1/3, or multiplying by 3, which is a lot easier. So those are going to cancel, and I get y plus 2 squared equals negative 24. Now, come back. There we go. Now I can take the square root of both sides. So I have y plus 2 on this side. On this side, that changed to square root of 6, square root of 4, square root of negative 1. Use your perfect squares when you can. They're going to make your life easier. So that's going to give me plus or minus, square root of 4 is 2, square root of negative 1 is I, square root of 6 needs to stay in the radical. Then I just need to move my 2 over by subtraction. So I get y equals negative 2 plus or minus 2i square root of 6. And you are done with 3-4.